Assalamualaikum warahmatullahi wabarakatuh. Let me introduce my team. We are from second team, and I am Jumaria Amanda as moderator, and there are Rahel Mendrofa, Jessicha Anastasya, Fadhil Akbar, Muhammad Aquila, and Afdallash Zibral Fahrisqy as presentator. Today, the topic of our presentation is combustion process in the recovery boiler. Okay, let's move on to the first presentation. I will explain about definition of recovery boiler. So, the recovery boiler is the most important and most expensive part of the craft recovery process. This is where the organic matter dissolved during pulping is destroyed and its energy value is recovered. This is where sulfates are formed and inorganic chemicals are recovered for reuse. Recovery boilers are an integral part of the steam and power balance in a plant. The economic viability of the plant is highly dependent on the efficient and reliable operation of the recovery boiler. Recovery boilers accomplish three main tasks: burns black liquid, recovers inorganic chemicals for reuse, and produce superheated steam. The recovery boilers consist of a water-walled furnace where black liquid combustion is completed, followed by a series of heat traps where hot combustion gases are cooled and superheated steam is produced. To understand any combustion process, it is important to understand that complete combustion requires an adequate supply of air, an adequate degree of mixing between the combustible material and the air, a temperature high enough for the reaction to occur, and contact time at a temperature sufficient to allow combustion to occur, reaction to raise combustion. These are the classic three T's of the combustion process. The first one, time. Function, smell, burning time. The second, temperature. The temperature required to change the smell to the dissolving tank. The last one, turbulence, or air. The faster it is, the faster the water will head. The next slide of the process stage part turn on the furnace, increasing the temperature of the furnace, will be explained by Rahel Mendrofa. Rahel, please welcome.
Okay, I'm Rahel Mendrofa and I'm going to explain the second part, which is the process stage. The first thing to do is turn on the furnace and increasing the temperature of the furnace. Furnace is combustion tool in the boiler recovery process. The furnace is turned on by flowing fuel in the form of liquid or gas simultaneously with black liquor, which is flowed slowly so that combustion occurs. This process is carried out until the temperature reaches the maximum level. Once the temperature has reached the desired level, the fluid flowing into the furnace is stopped and the black liquor that is flowing is slowly opened completely so that the combustion process is maximized and more efficient. That's all the explanation for me about turn on the furnace and increasing the temperature of the furnace. Thank you.
Thanks to Rahel. The next slide of the process stage for black liquor burning will be explained by Afdallash Zibral Fahrisqy. Afdallash, please welcome.
Hello, my name is Afdallash Zibral Fahrisqy. I will explain about black liquor burning that occur in recovery boiler. Burning of black liquor takes place in the furnace section. The furnace cavity can be considered to be the part of the water-wall enclosure, extending from the hearth to the tip of nose arch. The nose arch acts as a shield for the superheater section and helps tune the furnace gases so they pass through the superheater in a more or less cross-flow pattern. The furnace can be divided into the lower furnace and the upper furnace based on the function that occur. The lower furnace is where liquor is sprayed in, combustion air is introduced, the charbet accumulates, and smoke is formed to drain out of the unit. The upper furnace provides residence time to complete combustion and surface area to cool combustion gases. Traditionally, the tertiary air level was considered the boundary between the lower furnace and the upper furnace. Combustion air also enters the furnace through ports located on the walls making up the furnace cavity. There is considerable variability in how air is introduced. The lowest air level is called primary air. Primary air enters close to the heart from all four walls. Secondary air is located above the primary and below the liquor guns. It may be on two walls or all four walls, and there may be more than one lever. Tertiary air is introduced above the liquor guns, normally on either a two-wall interlaced pattern or concentrically. There are now units operating with quaternary air or even more air levels. That's all for me. Thank you.
Thanks to Afdallash, the next slide of the process stage part in organic chemical recovery will be explained by Jessicha Anastasya. Jessica, please welcome.
Hello, my name is Jessicha Anastasya. Now I want to continue present about inorganic chemical recovery on process stage steam boiler. The inorganic chemicals in the black liquor are recovered as molten salt mixture called smelt. It consists primarily of sodium sulfate and sodium carbonate with small amounts of sodium sulfide. The sodium sulfate, which is necessary for kraft pulping, requires a local reducing or oxygen deficient environment. The effectiveness of the recovery boiler in producing this desired chemical is measured by the reduction efficiency. The inorganic chemicals are much heavier than the combustion gases and tend to fall toward the heart. One feature of recovery boiler is the presence of charbet on the heart. The charbet consists of peel of the partially pyrolyzed black liquor solid, carbonaceous material, and inorganic the accumulate on the heart. Not all of the inorganic chemical process directly to the heart. Some of it from a fine dust, consisting primarily of natrium sulfate with, with some natrium carbonate which flow with the flue gases. This is collected in the electrostatic precipitator and returned to the black liquor being fired. In addition, some inorganic collects on her transfer surface and is removed by soot blowers. This material either falls directly to the hearth or is collected in as hopper and returned to the black liquor. There's presentation from me. Thank you.
Thanks to Jessica, the next slide of the combustion of black liquor will be explained by Fadhil Akbar. Fadhil, please welcome.
Thanks to the moderator, I will explain the material about combustion of black liquor. Black liquor combustion occurs either as the droplet sprayed to the furnace from a liquor gun or in the char pit at the bottom of the recovery boiler furnace. Black liquor is sprayed into the furnace through a number 4 liquor guns. In many combustion applications, the aim is to produce very small droplets to maximize combustion rate and temperature. Black liquor is not finely automated as it enters the furnace. Rather, black liquor is sprayed as coarse droplets. The first, drying. Drying is characterized by evaporation of water from the black liquor droplet. It is often experimentally defined by absence of combustion, visible flame. Evaporation of water requires heat. Drying of black liquor droplet process as fast as the heat is transferred to the droplet. Even in the furnace, temperature drying is limited by the heat flux to the droplet. The second, devolatilization of black liquor dries and temperature increases reaction with lowest activation energy start taking place. For organic fuel, release of low molecular weight component gas such as methane, carbon dioxide, hydrogen, and hydrogen sulfide star. Hydrogen, hydrogen, carbon monoxide, carbon dioxide, like hydrocarbons, tar, and like sulfur-containing gases have been reported to be main products gas during devolatilization. Devolatilization is characterized by the increase of black liquor droplet volume, release of volatile gases from the black liquor droplet, and appearance of visible flame. The last one is the most typical criteria for determining the length of the volatilization time in experimental droplet combustion studies. The third, char combustion. Char combustion of black liquor starts as the volatile release is finished. Often the combustible material remaining after volatile release is termed fixed carbon. Fixed carbon does not include inorganic ash. In laboratory tests, char combustion starts when the visible flame is extinguished. In practice, char combustion and devolatilization overlap considerably. Often a term organic combustion time that is the sum of devolatilization and char combustion times is used to characterize combustion. The four smell reaction. As the char combustion is finished, the inorganic residue remains. The black liquor droplet has first alerted and discharged to a liquid droplet. If oxygen contact smell, the sulfate in smell is reoxidized to sodium sulfate Na2SO4. In recovery boiler, it is important to have a non-reacting material on top of smell to avoid smell oxidation. Thank you. I return it to the moderator.
Thanks to Fadil. The next slide we will show a video about boiler working. Will be explained by Afdallash. Afdallash, please welcome.
Hello, it's me again, Afdallash Zibral Fahrisqy. I will explain about how exactly boiler working. The first draft fans blow air into the system. A portion is routed to the pulverized which crushes for fine dust Before pushing the mixture up through the feeder tubes, the, the other portion passes through an air preheater, which transfers heat from the exhaust gases to the incoming are raising the air temperature, reducing moisture, and producing a cleaner burn. The hub force there in cold, thus converging the wind box where the mixture is blown out. Through burners and ignited inside the firebox, transferring radiant heat to the water-filled tubes. The hot gases flow upward, eating the rest of the system through convection before passing through the air preheater and ultimately flow into the scrubber. Liquid water is pumped into the system at the economizer. Gradually, it's heated to this temperature before gathering at the steam drum. The system main distribution hub for circulating water and steam through the boiler. Liquid water flows through large tank hammers and into the base of the firebox, a network of 2-inch tubes in the firebox walls and burden force feed the continuously supply of combustible fuel into the ultra-hot firebox. Eventually, the inside of the firebox burns so hot that its surrounding steel walls would melt. Not out for the tubes line walls of liquid water at the point in the cycle when the liquid waters turn into steam. The steam separates the collects at the top of the steam drum because this saturated steam still contains small amount of liquid water that would cause corrosive damage to the turbo. The saturated steam is routed back into firebox and through superheats to burn off all but the smallest traces of liquid. This dry superheated steam then exits the boiler, passing through a steam locker and ultimately providing power to the spinning turbine, which generates electricity. Finally, exhaust steam, now at a lower temperature and pressure, is sent back to the boiler to the dedicated reheat stage. This reusable steam is brought back up to operating temperature before returning to the turbine, providing additional power through a secondary stage. That's all from me. Thank you.
Thanks to Afdallash. The next slide, we will show a video about liquor system. Will be explained by Muhammad Aquila. Aquila, please welcome.
Okay, thanks to the moderator. Craft recovery boiler are the key part of the liquor system in the paper and pulp industry, which are used to recycle chemical used in the paper pulp making process, such as soda ash or sodium hydroxide and sulfate sodium sulfate. The following is a brief explanation of the craft recovery boiler. Number 1. Main function. The craft recovery boiler is responsible for recycling the chemical contained in black liquor. The liquid was resulting from the paper pulping process. Black liquor contains decomposed wood, pulp, and chemical used in the wood fiber separation process, such as soda ash and sulfates. Number 2. Combustion process. Black liquor is fed into the craft recovery boiler, where the organic material contained in the black liquor is burned. The combustion process produces heat which is used to produce steam which can then be used to drive a turbine and produce electrical energy. Number 3. Chemical recovery. In addition to producing energy, the combustion process also allows for the recovery of chemicals contained in black liquor. The chemical obtained from this process can be recycled in the paper pulping process. There will be minimizing waste and increasing process efficiency. And number 4, importance of craft recovery boiler. Craft recovery boiler are very important in the pulp and paper industry as they not only help in recycling chemicals and producing energy, but also help reduce environmental impact by reducing waste and greenhouse gas emission. Thus, the craft recovery boiler is a key component in the liquor system in the paper and pulp industry, which play an important role in supporting the sustainability and efficiency of the production process. Thank you. I will back to the moderator.
Thanks to Aquila. The next slide, we will show a video about fundamentals will be explained by Rahel Mendrofa. Rahel, please welcome.
Next, I will explain about craft recovery boiler fundamental. The craft recovery boiler has many tubes located in the combustion gas stream. They collect the heat of combustion and convert the energy into steam by heating boiled feed water inside the tube. The heat transfer section, there are three main sections of tubes in the superheater, the generator or boiler bank, and the economizer. Feed water enters the economizer and then flows to the steam drum. The steam drum is a large cylindrical vessel situated horizontal across the boiler that acts as a reservoir of feed water in the boiler bank. The water wall tubes are part of the feed water circulation feed from the mud drum and steam drum system. The steam drum is connected to the mud drum by multiple boiler tubes. The mud drum also provides the blowdown point where feed water impurities are continuously drained to the sewer choke, a small pipe. That's all from me. Thank you.
Thanks to Rahel. The last slide, we will show a video about Fahrisqy. Will be explained by Jessicha Anastasya. Jessica, please welcome.
The fire side of the recovery boiler is where the combustion of the strong black liquor and the chemical recovery process simultaneously take place. Strong black liquor enters the recovery boiler from the broomstock, water containing 65% to 85% dry solids. The recovery boiler uses strong black liquor as its main fuel and during normal operation. Function with black liquor as the only fuel. The cooking with chemical flow out the recovery boiler as molten salts are smelt and the are turned into green liquor in the dissolving tank. This green liquor is sent to the casing process from conversion to white liquor. Thank you.
Thanks to Jessica. Thank you all for listening of presentation today. Wassalamualaikum warahmatullahi wabarakatuh.